Deepspar, located in Ottawa, Ontario, is a data recovery company, but not in the way that you might think. Like, you can't just drop in with your dead hard drive and ask them to fix it for you. Their business is developing the software, hardware, and the techniques that are used by everyone from mom and pop shop technicians to huge data recovery houses. Right on the other side of this wall is actually the classroom that they use to train police and other government agencies on data recovery. So they sponsored our trip out here to do two things. One, to show consumers how to save money on data recovery service, and number two, to show repair shops how they can dramatically improve their chances of recovery for their customers. Scenario one of hard drive failure is clicking and clacking noises, sometimes without being detected by the system. Ooh. Okay, if this happens, it's probably a physical problem. So if the data is important, don't do anything. Unplug your drive and send it to a pro immediately, or your chances of a successful recovery will be dramatically lower or possibly even zero. A pro is going to use tools like these and a laminar flow workstation like this one, or even a full-on clean room like the one that I checked out over at Drive Savers to physically swap components into the failed drive from donor drives. Sometimes this needs to be done multiple times in cases where one bad part is causing the other ones to fail prematurely. They'll also use professional tools from companies like Deepspar. So I didn't know it, but I was actually using Disk Imager 4 when I performed my own head swap in that video. Scenario number two is an electronics problem. Maybe a broken SATA connector or a burned chip on the PCB could be causing the drive to not be detected by your system. The most common symptom here is total silence. Now, sometimes you will need to call a pro for this. And if the data is mission critical, you should always call a pro. But for nice to have rather than need to have data, this type of failure actually exposes the platters of the drive and therefore the data to much less risk. So in some cases, you can attempt a home repair if you're handy with a soldering iron. Now, Deepspar had this whole demo planned for me. The TVS chip actually handles overcurrent protection for the drive and can fail due to an external issue. So just removing it from the PCB can possibly brick the drive because you're removing the overcurrent protection, but in many cases, it can allow the data to be recovered if it's hooked up to a known good system and power source. But we are throwing that demo out the window because I brought Deepspar an unexpected present. This is Taryn's personal dead hard drive that failed when we hooked it up to a faulty power supply cable while he and I were at the office late upgrading his system. Now, he would likely be quoted $300 to $500 US minimum to fix this. And since he's Taryn and he doesn't remember exactly what's on it, he's not gonna pay that much to get it back. So we're gonna see how we do with a DIY grade repair. Yarrick, you ready?
Sure, let's have a look.
So what we're gonna do first is we're gonna verify the diagnosis. Now, I'm already pretty sure that we're gonna power up this drive and we're gonna hear a whole lot of nothing. So that means there's a good chance that this is an electronics problem then.
That's what usually happens when you use bad power supplies.
Okay, so we power down.
Now let's try to replace the board.
Now, unfortunately, swapping out a PCB on a drive isn't as simple as going to the hard drive PCB store and buying one.
Yeah.
Yeah, if only life were that easy, right? Yeah, sure. Look at him, he's defeated. He's defeated. So eBay and Craigslist are your friends. Now, fortunately, in Taryn's case, he already had a donor drive that looks like it's gonna be suitable. So there's a couple things to watch for. You need the drive model to be the same. So not just this drive model, but also this model number right here. So these look good. And you even need the PCB revision to be the same. Now, these two are a slightly different color here, but that's not important. What matters is that they're both revision A and they both have exactly the same model. So these should theoretically be suitable.
They look perfect.
Okay, now we're at the point where most amateurs would screw up this kind of a recovery. They'd go, okay, well now we take the good PCB, put it on the bad drive, and bippity-boppity off to the races, right? Wrong. Data density on modern drives is so high that the manufacturing tolerances are nowhere near good enough that every drive will just work out of the factory. So they have to build in compensation and calibration that is unique to your individual drive. It's usually stored on a little 8-pin ROM chip that looks like this. And that specialized data has to be brought over. So, want to show us how to desolder and resolder a ROM chip?
Yeah.
All right, let's do it. Let's not screw these up. Which one's which? Oh, D on this one.
Yeah.
Okay, we're good. Okay.
Yeah, it's better to mark it first.
There's a pro tip right there, my friends. Better to mark it first. Now we're ready to put the PCB back on and we can go test it, right?
Yeah.
All right. Now we're ready to try again. Here goes nothing. It's not picking up. Do you want to have a look at it? Okay, so unfortunately, sometimes when you hook up to a bad power source, it kills more than one thing. So we've fixed our PCB problem, but we're still getting this zero capacity nonsense here, and we're getting kind of like a chirping noise. And Yarrick, like, drive whispered, like the horse whisperer for hard drives over here, and told me that what he thinks is that it's the pre-amplifier chip. So that's a component of the drive head, which means that we actually need to dig a little deeper on this thing. We're gonna take it over to the laminar flow workstation and tear it apart. So what this station does is it uses a really thick filter here to pull all the dust out of the air, and then you've got this constant flow of clean air so that none of the contaminated air around us can get into the drive. That's really important. With how close the head is to the platter, even the smallest speck of dust could cause catastrophic damage to the platter as it's flying over it. So now we're swapping the known good heads from the working drive into our bad drive. And actually, now that I come to think of it, by known good, I mean I have no idea. I have not actually tested this drive. Presumably Taryn checked it before he gave it to me. If it helps at all for the tension of this situation, I still don't know that this will actually work the way we want. I mean, we could have screwed something up, right? What's your confidence level right now?
I would give it 80%.
That's not bad. All right, let's go give it a shot. So this is it. Moment of truth. Now, I'm not superstitious, but I'm gonna cross my fingers. I'm not gonna knock on wood though, because then we might like bump the drive. Hey, no! I think we're gonna get it. Now, that's actually a really important point. Just because we are able to read data off of this drive does not mean that Taryn can take it, pop it back in his system and start using it again. This is still a dead drive. So what we're doing right now is we're pulling a bit for bit copy of all of the data off and we're putting it onto a new one. We are imaging the drive at 97 megabytes a second.
Keeping your fingers crossed.
No, sorry. Sorry, okay, so what, I have to do this for another 6 hours? 6 hours. Scenario number 3 is a firmware problem. Now, for unusual issues, deep knowledge of hard drive firmware design and a professional tool like a PC3000 is necessary. But the fees that you can expect to pay to someone who can interpret this matrix level stuff right here would be anywhere from $500 to easily thousands of dollars, depending on the complexity of the problem. The good news is that many common firmware issues can actually be solved with pretty much a button press. And that is where Deepspar's tool, the RapidSpar, comes in.
The drive still works, kind of.
Oh, here we go. Well, hold on a
really
second.
Those are just
Yeah, we've got
partitions.
3 partitions off of it already though, and then we're just waiting on.
Partition is still loading.
What a frustrating and tedious line of work. But you get to deliver people their data back.
Not us, our customers.
Right, but someone gets their data
Someone.
back.
So it only took 5 minutes.
There we go. Okay, so now then we're good. It's just that every time we have to plug in this drive, it takes a long time to detect.
Oh sure, yeah. Let's see what happens when we try to copy files.
So wait, so everything is slow like this?
Correct.
You look very satisfied right now. So, yes, this drive is broken exactly the way I wanted it to be for this demo. Funny story, I was actually here 2 weeks ago, but we lost part of the data from that shoot. Last time we were able to show that the data was transferring at such a speed that it would take infinitely long to get it off, meaning that the drive would be guaranteed to be dead by the time we actually managed to recover anything from it. But it's going even slower. Why?
It's just getting bogged down doing something that it's not supposed to be doing. So instead of giving us the data, it's just kind of running in circles. Eventually, it's just not going to identify whatsoever. But we'll still be able to fix it because it's only a firmware problem. So we are going to stop this process and we're going to connect our drive.
And this is completely custom hardware and software, is that right?
Correct. We built everything from scratch. It's made in Canada as well. We coded everything from scratch in assembly code.
The reason is that off-the-shelf operating systems make certain assumptions about the hardware, namely that it works. So as soon as the hardware doesn't work, it starts running into issues, and that's why any software product is going to get stymied by certain drive malfunctions. Whereas when you build your own thing from the ground up that expects problems, well, you can have a different experience. So what Surge is doing right now in their software is he's running a diagnostic test on the drive to determine what exactly the firmware problem is. So this process takes a couple of minutes, and what it's doing is it's going through and it's finding any discrepancies in the firmware of this drive compared to what's supposed to be there, and then it's overwriting them. And that doesn't make it so the drive loses any data. No, okay. So now all that's left is power down the drive. Touch interface.
Yeah.
Nice touch. Huh. Then, theoretically, we pop this guy back into our drive dock here. And now, oh, I thought I heard. Sorry, okay.
Yeah, it's off.
Power on the drive. Hey, there it is. Oh, that's way faster. Of course, though, the acid test is a file copy. Can we get data off of this drive now? Now that discovery process is going faster. Hey, there we go. This is much better. Awesome. Here we go, there we go. Fantastic. So with the RapidSpar, we went from not being able to copy the data at any kind of reasonable speed to now we are copying all the data off this drive. Now, one of these guys does cost about $2,000. So end users aren't expected to buy one, but since it's so simple to use, if you, the end user, can find a shop that has one, you should expect to pay about $300 for a recovery that it can handle. So, I mean, maybe that's still not worth it for photos of that night of binge drinking or whatever, but if your tax records and your will are on your hard drive, it's worth considering. In scenario number 4, we're going to see another solution that you can actually try at home, and this time without any specialized tools. All we need is a USB drive dock, our drive, and a computer. So this is an example of logical corruption. We're going to go ahead and plug in our drive and power it on, and you're going to see something that you might have seen before. So this can be caused by accidental formatting, viruses, or Windows errors. See this? You need to format the disk in drive D, but hold on a second, I had data on this. Okay, step number 1, don't click format. Click cancel. Then we're going to use a software called RStudio, but there are actually free options out there that are somewhat similar. We're going to go ahead and we're going to click on our drive here. We're going to double click empty space, and if it's not actually a hardware issue, dun, 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 so no bad sectors, and look at this. Here's all our files. They are ready for recovery. Fantastic. This type of software can also help us diagnose scenario number 5. So the thing is that unless you drop it or something, a hard drive doesn't generally go from working perfectly to completely dead in an instant. Read instability almost always comes first. And these types of drives, these mostly dead drives that haven't fully failed yet, make up the majority of cases that get sent in for data recovery. The symptoms of these drives can include not being detected in the BIOS, preventing the computer from booting, spitting out random errors, or just getting so slow that you can't do anything with them anymore. You shouldn't have any noticeable knocking or clicking yet. And that's exactly the situation. So we're gonna fire up RStudio here, and oh, that's interesting. Our computer is completely frozen up. One of these partitions has shown up, but this one's just not populated. Here's a little Windows hack that you might be able to use to get access to a drive like this. All you need to do is start up the command prompt as an administrator, start up Windows's built-in partition tool. Oh, right, the computer's completely locked up. I gotta power down this drive first. There we go, now everything comes back. Then we just need to run a couple of commands, auto mount disable and auto mount scrub. With our tweak, what's gonna happen here is that Windows isn't gonna try to load a drive letter. And that's actually a good thing, because it can hang the entire operating system while Windows tries to mount the file system, and it'll try and then time out, and then it'll restart and do it forever, doing more damage to what is already a damaged drive in the first place. So now that we've done this, we can open up disk management and boom, there it is. There's our 300 gig drive, and we can actually launch our RStudio software now because the system isn't completely locked up. In cases where the drive doesn't have a ton of bad sectors, we actually can attempt a recovery. That's looking pretty. Oh, this is taking longer than it should. So this is the point where, as a data recovery technician, your gut feeling should be to stop what you're doing, because we're only 17% of the way through, and this drive has many bad sectors, which are taking anywhere from 1 to 3 minutes to detect each time. Now the problem here is that this is a typical software behavior where the drive encounters a read error and it just keeps trying and keeps trying and keeps trying. This puts a lot of strain on the drive and can cause it to fail right in the middle of this type of recovery attempt. So we're gonna switch over to the Deepspar and talk about that method. So all we're gonna do is plug our drive in here, go ahead and power it up, and then there are a couple of things that might make us think that this, the Deepspar, is gonna work better than a standard computer. For one thing, if it encounters a bad sector, instead of reattempting and reattempting, wearing out the drive, it will actually cut off its reattempts after a couple of 100 milliseconds. This dramatically reduces the stress on the drive. For another, it actually borrows a lot of DNA from their higher end products. So this is the disk imager. So when we set our source drive parameters here, we select the brand and the interface, and what it's doing is it's actually taking information about the behavior of our drive as it scans it, and it's uploading it to Deepspar servers where it compares it against a database. Their server then sends our Deepspar some recommendations for how to deal with it to help accelerate the recovery. Pretty cool, right? So we can double click partition 1 here, and boom, we're running a scan. So you can see here, we already hit one of those bad sectors, but instead of trying for 2 minutes, it's only gonna try for a couple of seconds before it moves on. Now we're never gonna get back any data that was on those sectors, but at least we can get back whatever's on either side. So check this out, we didn't get everything. You can see there's some corrupted stuff here, but even though this drive had hundreds of bad sectors, instead of taking 2 minutes every time it hit a bad sector, this whole scan only took us about 7 minutes. Much less wear and tear. And there's some other cool stuff too. For this trick, we need a drive that is in much worse condition. Let's go ahead and power this on. That's the hard drive. That's less fine. That's not fine at all. Turn it off. But the Deepspar has another borrowed trick up its sleeve. So all we gotta do is plug this in, but we're not gonna power the drive on right away because we don't want it to start thrashing. Instead, we're gonna let the software interface power on the drive and then start issuing commands to it immediately so that it doesn't get a chance to try to click itself to death here. So it's powering it on, and then hopefully we're not gonna hear a ton of clicking, because that would mean the potential for our dead head to cause our other head to fail. That's something that's really common. Once you've got one head gone, the other ones tend to follow suit. Okay, smart failed, okay, that makes sense. Now in a moment here, it's gonna start checking the heads and media. We're probably gonna hear a couple of clicks here because you can't check if the head works without trying to move it. Ooh, not good. Diagnostics are done now, so 19% of our tested sectors do contain data. There's something to recover here. As we expected, one of our 3 heads is at 46% health. Now, we're not getting back anything that's on that platter with the bad head unless we do a head swap and put a new head in the drive. So if this stuff isn't mission critical, what we're gonna do is we're gonna build a head map here, then we're gonna disable that head and see how much of the data we can pull off. All we gotta do is click this, skip anything on head 1, click apply, and now we're getting a new sector map by heads. Here comes our files and directories, and boom, there it is! File tree, baby, love it! And through all this accessing, you don't hear any clicks anymore because that head has been parked as long as we're using the RapidSpar. So this thing is really cool, but to be clear, the RapidSpar is also not magic. So of the jobs that come into your shop, some of them are going to be solvable with software, and then of the ones that remain, about half of them can be dealt with the RapidSpar, and then the other half are still going to have to be outsourced to a professional that's armed with more powerful tools and probably a clean room. So Disk Imager 4, along with the software that accompanies it, allows very fine control of things like the reattempt threshold. It has a ton of configuration knobs that a professional can tune, and can be used to work on drives that the RapidSpar can't even interface with yet. Like, for example, a PCI Express NVMe SSD. The RapidSpar can handle a regular SATA SSD, which, by the way, can have bad sectors as well. So that's pretty much it. So hopefully, whether you're an IT manager or you run your own shop or you're just an end user, you've gained some knowledge about the data recovery business and how it works behind the scenes. Now, of course, Deepspar, just want to throw this in, Deepspar values your business, but any video about data recovery would be incomplete without a reminder that in a perfect world, you wouldn't need it. Please back up your data, because the Deepspar guys would love nothing more than to live in a world where no one loses their data and they can just sit on a beach somewhere drinking cocktails instead of hanging around with me all day. So thanks for watching, guys. If you disliked this video, you can hit that button. But if you liked it, hit like, get subscribed, and maybe consider checking out where to buy the stuff that we featured in the video description. This would be a great addition to any tech shop out there. While you guys are at it, we've got our merch store listed in the video description as well, and a link to our community forum, which you should totally join. I swear, you guys have more dead drives than most stores have working drives.